Good morning, everyone. Everybody hear me okay? All right, we are very excited to be here today and talk to you about how you can use agents in space. And so I know you've gotten a lot of overview of AI throughout yesterday. You're going to get a little bit of an overview today as well before Nelli jumps into some awesome demos, because I think it's always more powerful when you can see it. So I'll skip over that. That's us. We don't want to be up on the big screen. So, we talked a lot yesterday about agents, what are agents good for, and what is really agentic AI. So at its core, agentic AI for us refers to AI systems that can make decisions, take actions, and pursue goals on their own. Unlike traditional AI that waits for specific instructions, agentic AI has that kind of agency where it can figure out how to solve problems by itself based on the goals that you, the user, give it. AI agents can take actions on your behalf. Think of it like the difference between a basic AI, like ChatGPT. Think of that like a vending machine, right? You press a button, it gives you an answer. It gives you a snack, what you want. Agentic AI, on the other hand, is more like a helpful assistant. You would tell it, I'm hungry, and it would know what's in your pantry, what it is that you like, and then perhaps make a meal for you or tell you what to make. So it automates that complete workflow end to end. That's what we're referring to when we talk about agentic AI. And so before we dive into that, let's ground all of ourselves in the broader arc of AI progress. Because what we're seeing right now isn't just another incremental change. It's actually a true inflection point. Over the decades, AI has moved from several major waves of innovation. In the 1950s, we began with the foundational idea of artificial intelligence, the ambition to build machines capable of reasoning like humans. 1959, machine learning emerged, shifting AI from rules-based systems to models that learn patterns from data. It kind of stayed that way for a relatively long period of time. Sure, there was innovations, but I think about 20 plus years ago when I was in school, that's what we learned about. We learned about AI, we learned about machine learning. When you fast forward to 2017, where deep learning went mainstream, that unlocked some of the breakthroughs that you've seen in computer vision, speech, natural language processing, by stacking those layers of neural networks. Then came generative AI, transforming how we view content, right? Writing, imagery, audio, and more that was based solely on prompts. Now we've hit that new milestone, agentic AI. This isn't just about generating content. It's about taking action. Agentic systems combine knowledge, memory, planning, and orchestration together. They can make decisions, adapt to new information, and execute tasks end to end. Think of it as a shift from a passive AI assistant to an active collaborator. We're no longer talking about models that simply answer questions. We're talking about agents that can autonomously plan, coordinate, and perform across those complex work processes. This is what we refer to as that new moment for AI, where intelligence becomes operational, not just informational. And it's how we redefine how organizations will innovate, deliver, and drive value at scale. So when we think of agents, we think of them existing on a spectrum. Different organizations are at different stages of their AI transformation. Some are advanced, building the next generation of agents to focus on retrieval and task experiences, bringing their knowledge and automation into their agent experiences. These descriptions aren't official technical names for your agents. They're used to describe the capability that your agents may possess. All agents have the same set of components. It's down to the makers to define those use cases and the complexity and where it sits across this continuum. So sometimes, we hear, oh, that's not really an agent, and I'll walk through this in a little bit, but really they sit anywhere on this continuum. And as an individual organization, you could have multiple agents. Some might be focused on retrieval, some might be focused on tasks, and some might be autonomous. That's okay, right? You can define that for your organization. So why are agents transformational, and why do we need them? Let's look at how the capabilities have evolved over time to bring more efficiency, value, and strategic advantage to business. So starting on the left, you see the agents of yesterday, which really wasn't that long ago, right? You see technologies like robotic process automation focused on completing those repetitive tasks, such as inputting new hire information into an HR system, as an example. They were efficient for structured, rule-based workflows, but limited to a specific function that you gave it. The next step was what we're all familiar with, right? The chatbot that was able to answer questions. What's the dress code for the office? Should I dress in a suit? Should I wear jeans? So it provided that immediate response, but it still lacked the ability to take a meaningful action. Moving to today, we see the emergence of a single AI agent and also multi-agent systems. So when we think of a single agent, it's able to take an action. I happened to hire somebody yesterday. That single agent realizes that I hired somebody and is going to order them a laptop. But a multi-agent system is going to realize that I hired somebody when their start date is, going to reach out to me to confirm their laptop, going to reach out to that employee, confirm their address, and then send it to their doorstep. And then they're going to get another question from an agent. Did you receive it? Yes. Perfect. Right? That's what we're talking about. Think about how many emails that would have been back and forth in the systems of yesterday, where that's completely automated end to end. And so Nelli and I joke sometimes that I'm very focused on efficiency and saving time. That is how I structure my day. Anytime I can save a single minute, that's a minute I could be doing something else. And that's one of the most valuable things to me personally. That's what this allows you to do in an organization. It's getting those minutes back, and it's getting those minutes back at scale across the organization. So when we look at this, we see that the trend is clear. We're moving towards a future where AI not only actively unlocks that cross-functional collaboration, but it unlocks that new level of efficiency and advantage for businesses. So we're transitioning from those static AI experiences to dynamic multi-agent ecosystems that continuously learn, optimize, and scale. So what this slide is meant to represent is that shift in how organizations design and deploy AI applications. We're moving from a world of simple, isolated solutions to one where AI is dynamic, interconnected, and continuously improving. This older model on the left-hand side was limited, it was static, it required significant manual effort at every single step of that process. On the right, you see where we're headed. Those multimodal architectures, that automated agentic workflow, that continuous improvement, right? ROI always continuing. This shift represents an entirely new generation of application development, one where AI isn't just assisting with tasks, but increasingly orchestrating those developer workflows. Now your developers, who before were focused solely on writing code, testing code, making sure that code functioned, can focus more on strategy and less on that manual implementation, because AI is accelerating their ability to take those coding actions. This slide highlights the 4 major pillars for an AI-driven transformation. Now, if you've ever seen a Microsoft presentation before, you've seen these 4 pillars, but it is how we operate, and it is how we, coach in our presentations for our customers to operate. And I love the way this talks about the internal versus the external impact, right? There are things you can do that makes your organization more efficient internally, makes you operate smoother, makes you take less time to take those actions, and then there's what you can deliver for your clients or your customers. And so when we talk about reshaping business processes, one of the things that we do as a company is we have a company-wide effort to rethink every process through an AI-first lens. Tasks that once took really, really large teams, like potentially supporting a legacy application or a product, are now handled partially by AI, freeing those engineers to focus on higher value work. When we talk about enriching employee experiences, we deployed M365 Copilot across a broad swath of our organization very, very rapidly. And then we measured the productivity gains that were there. And so it wasn't to replace anyone, right? It paid for itself by amplifying that human capability, not replacing it. You can do your job more effective, more efficiently. You can have more meaningful impact. And then on the right-hand side, you see reinventing the customer experience. So again, just talking internally, we manage millions of incidents every year. But by deploying agents to triage those signals and route those issues and support outcomes with a co-pilot, for each of those use cases, we're able to deliver faster resolution times and do smarter root cause analysis that improve our response for any kind of future incidents. And finally, accelerating innovation. So this data point is a bit dated, but last year we publicly said that we had produced more products in the last year than in the last 3 years combined. And a lot of that is due to the acceleration of GitHub Copilot. It contributed to over almost a third of all the code that was developed for our other copilots, proving that AI dramatically shortens that development cycle and unlocks creativity and speed. So together, these 4 pillars show how AI, especially agentic AI, is reshaping organizations from the inside out and driving impact across employees, operations, customers, and innovation. Now, this is probably the most powerful visualization, for me at least, in this entire presentation. On the left, we see how many organizations in the world operate today, right? Information is slowly processed. There's a hierarchy. See if my build decides to work, right? Humans, traditional tools, machines, they all operate in their own silos. They're not necessarily collaborating together across the board. On the right, you see where we're headed. A fully integrated environment where humans, AI agents, and machines collaborate seamlessly together. Information flows quickly, systems are connected, AI can dramatically adapt to complex goals. This isn't about doing old work faster. It's about redesigning how work happens altogether. So we analyzed and surveyed 31,000 workers across 31 different countries, industries. We looked at LinkedIn, market trends, trillions of productivity symbols. And what's emerging is the concept of a frontier firm. That's an organization that doesn't just use AI to generate information, but uses AI to orchestrate it. In these models, humans shift from completing the tasks to coordinating and directing a fleet of intelligent agents. The organizations that thrive will be the ones that can align that human intent with intelligent systems, turning overwhelming data into meaningful outcome. AI agents won't replace human work. They're going to elevate it by taking on complexity so people can focus on judgment, creativity, and mission direction and outcomes. So the frontier firm looks markedly different than those we know today. Structured around on-demand intelligence powered by hybrid teams of humans plus agents together, companies can scale rapidly, operate with agility, and generate faster value. So in the first phase, AI is acting as that assistant, helping people work better and faster. In the second phase, agents join teams as digital colleagues taking on specific tasks at human direction. For instance, a researching agent creating a go-to-market plan for you. In phase 3, people set directions for agents to run entire business processes and workflow and then check in with them as needed. So picture, if you will, how a supply chain manager role may evolve, where agents are handling the end-to-end logistics while humans guide the agent system. They resolve exceptions to the process, and they manage that supplier relationship, that human-to-human interaction. Human work isn't replaced. Again, it's elevated. It's a common theme. And this journey is not going to be linear. Most companies will be in all 3 phases of this journey simultaneously as you work to really reinvent the way you're doing business. So as I just explored, agentic AI represents a major shift, moving from systems that simply respond to instructions to systems that can take direction, take action, carry out end-to-end workflows. Now we're going to ground ourselves in and now we're going to look at the frameworks, platforms, and tools, that make it possible. And so I promise I'm not going to talk about a whole bunch of Microsoft products and names and give you a sales pitch, but I want to ground you in what it is that Nelli is going to be talking about so you can really understand. Every AI application we build runs on what we refer to as Foundry. And so Foundry is the platform that powers all of our copilots. And these are just some of them, right? Whether it be Microsoft Copilot Chat, whether it be M365, Copilot, Security Copilot, Dragon Copilot, or GitHub Copilot. So like regardless of the scenario, whether it's productivity, security, development, or industry-specific workflows, they're all using Azure OpenAI models inside of Foundry. And I'm going to show you a little bit more about Foundry in a second. But that consistency gives us the reliability, security, and performance at the scale that's needed and ensures that every experience is grounded in the same enterprise-grade infrastructure. So we offer a variety of agentic frameworks for different levels of agent complexity. These frameworks cater to a range of needs, from building simple agents to managing those large, complex systems I spoke about earlier that require the coordination across many specialized agents. Agents can call each other as tools, connected agents, if you will, passing tasks between those specialized agents to solve those complex problems collaboratively. New multi-agent workflows provide a stateful layer to manage context, handle errors, and maintain those long-running processes. Great for scenarios, again, like supply chain operations or financial approvals. And then we have the agent framework, which is an open source engine for building and orchestrating those intelligent AI agents using open standards and interoperability. We've implemented standards like agent-to-agent, A2A is how it's commonly referred, communication, and that Model Context Protocol, or MCP, which I'm sure many of you have heard of, to enable agents to cooperate and collaborate across not just our products, but also other clouds and on-prem environments. So when we talk about building AI applications, everything starts with that model. That's the core intelligence behind the solution. Foundry gives organizations access to the widest array of models on any cloud, with more than 11,000 foundational open source, multimodal reasoning, and industry-specific models. The key advantage here is flexibility. You can explore, you can evaluate, swap models quickly without being locked into a single vendor or an architecture. And so you can see some of them here up on the screen. Developers can benchmark the models, understand performance trade-offs, and seamlessly switch between them using that unified API. This means you can optimize for accuracy, for cost, or latency, depending on the application that you're using. And all of these, if operated within this framework, also come with SLA, compliance. You can take cost savings, share PTUs, provisional throughput units, across and among those models. Now let's get to the heart of the presentation. And Nelli's about to come up here, which is going to be way better than me standing up here talking to you, I promise. All right. So what are some of those agentic AI use cases specific to space missions, right? We're here at the Space and Rocket Center. I love standing under the big rocket next door. But how could we use that and envision that within a space-based mission? And so you can think about operations in spacecraft healthcare, right? You could autonomously do telemetry triage. Agents can scan all of that telemetry that's being generated, detect anomalies, prioritize alerts by criticalities, and propose mitigation steps. So it's not a human trying to analyze all that information that's coming in very, very rapidly. Can do fault detection, isolation and recovery, reason over that subsystem behavior, simulate those failure cascades, and recommend corrective actions and maneuvers. Think about dynamic mission planning and scheduling. Agents can replan science activities based on resource constraints that may be there, orbital changes, weather, new data. You can do autonomous maneuver planning, right? Burns, station keeping, docking, proximity for reasons about safety envelopes and constraints. All of that can be tested by leveraging agentic AI. You can do onboard data processing, determine which data to downlink first, right? If your network is, limited, as an example. And then think about crew safety, right? You have astronauts in space, right? They might get ill. And so, sure, that AI is not going to be the doctor, but it can provide them recommended steps on what they could do, because what they're experiencing in space might not be the same that they would experience it on the ground. And then ground operations and mission lifecycle, which I think, this is showing you in the context of space, but we're a pretty large aviation community. It would stand to reason that it could apply there too. Think about schedule optimization, who's going to fly when, et cetera. All right. Now I'm going to turn it over to Nelli. She's going to touch briefly on security, and then she's going to show you all the demos.
Thank you, Heidi. And let's talk security. I had to miss yesterday's panels because I live in DC area and we are snowed in and I had a 10-hour delay. So if you didn't ask any questions about security yesterday, please do today. And you always should ask those questions about security when you're dealing with AI, and that's something that we want also to get ahead of. So how do we handle security? And you heard already that Heidi and I will work with federal customers, so the US government, and security questions are paramount. But those should be paramount also for anyone else who is dealing with AI or any other technology. So how do we handle security, or how do we approach it from the Microsoft Foundry perspective that Heidi was talking about, right? That platform that powers all of our AI innovation and goes into our various co-pilots that she also mentioned. There are specific features and capabilities that are infused into our AI capabilities that look into network isolation, meaning that there's your network, and only those who are authorized to be on that network can access it and can also use the AI capabilities within your various applications. Same goes to identity and access control. It's, to some extent, also need-to-know basis, right? If you are looking for some data, do you actually have access to that data that can be surfaced through your AI-powered application? Data protection, it's really about knowing where is my data, what kind of data I have, who has access to that data, or who can get access to that data for specific workflows, right? So all of that is very important when we're talking about AI also. Building AI applications doesn't mean that, oh, here's my agent, I built it, then it can go there and sit and maintain itself. There is a lot of policy and also monitoring involved. You need to make sure that you have continuous monitoring in place to make sure, again, your data is protected. Everyone who has access to that agent is supposed to have access. So this is what we talk about when we're saying platform trust and trusting what you're doing with AI when you're building your agents, and also making sure that you are compliant within your industry with various regulations that you may have that are also already baked into our AI capabilities. And I talk to all of our customers, and Heidi talks to all of our federal government customers, and also some on the commercial side. And we're often talking about how they can successfully, securely, and effectively adopt AI and develop those agents. And very often, as we're discussing their use cases, as we're discussing how they want to adopt AI, we take a step back and try to understand what is the data readiness situation, right, with this organization. Is their data actually ready for AI? Because you may have heard the phrase, which everyone repeats these days, garbage in, garbage out, which means that your AI model, your large language model, can be very skillful, can be very good at retrieving information, synthesizing information, aggregating, summarizing, creating new data. But if the data on the back end that goes into that model to retrieve from is not ready for AI, or it is not that golden source of truth or authoritative source, then the performance would not be what you're expecting. And this is why we talk about preparing your data, right? Preparing your data, making sure that it's clean in data science speed, it's normalized, and then only then presented to your AI agent. Discovering the data is, again, really about knowing what type of data you have, where that data is, who has access to that. You are protecting your data, making sure that, again, only those who have are supposed to have access based on their roles, based on specific conditions, can have access. And then, of course, governing that entire process, making sure that you are continuously monitoring not just the compliance of your data, but also of your AI agents. And this is why we say, again, also to our customers that let's innovate with purpose, and not just really go with the hype of AI, but understand what are those use cases that you are trying to solve. And this is when I always tell our customers also, forget about the AI for a second, and let's talk about your challenges, your requirements, your pain points, what we're trying to solve, and then we can definitely find a solution for you, or build some kind of an agentic framework. And speaking of those use cases that are very important to take into consideration, let's talk about one that is really around science. NASA is everywhere in Huntsville, so it does a lot of science, right? Very exciting one. So I want to talk about an agentic framework for a bit that is purpose-built to help with scientific discovery. And very aptly, this one we didn't name Copilot, this one we named Microsoft Discovery, just to spice it up a bit. And this is really providing you with that whole agentic framework that can help you with from the very beginning of your scientific process. The generation of your hypothesis, or rather, let's say literature review. In my days when I was doing my PhD, literature review was my least favorite thing to do. Because you have to scour through all of these books, articles, and journals to find that one quote that can help you with generating your hypothesis, and that a lot of time is spent on that, right? I wish this was available when I was writing my thesis, but this is really what it helps you also with. That beginning process of literature review, let's say, and then generating your hypothesis, validating your hypothesis, testing it, and then coming up with something that hopefully may revolutionize your field, right? So this is an agentic framework that we have put together that can be applied to chemistry, to life sciences, physics, and any other types of different disciplines and fields. And going a bit more into detail, here you see that I'm really talking about. So this is the platform that is Microsoft Discovery, where you can try those different prompts. You can add your data from your field on the back end, and in this environment, you can start exploring that data, and the models, and then set up a workflow that will help you with understanding how my hypothesis is generated. I can ask some questions there, and then get it to start doing the fun stuff. So this specific demo is really about one use case, which is trying to find an element for a coolant that can go into the data centers. We're Microsoft, we have lots of data centers, and we're always on the market to find how we can best cool it without using too many resources, right, to be more sustainable. So this is one of those ways that it's not just creating a product that for our customers, but it is also something internally that we can use. So in this specific example, we are looking, I'm going to fast forward a bit. We're talking about how we can find that element that can create a new coolant for the data center. So that agentic framework on the back end is doing all the retrieval from literature, finding the information, generating hypotheses, running simulations that can take very long time if you're doing it, for example, in a wet lab, and then coming up with some ideas and possible chemical equations there. And then finally, this is not theoretical, this is actually something that our Microsoft research arm did. Then find that specific element that they can put in a coolant and then test it in real world. And instead of spending years on this, this was done within a couple of days, right? And this is something that actually can be used now in the data centers to provide more efficient cooling. Another example of such an agentic framework, we're dealing with lots of interesting data, is our collaboration with NASA. So you have all probably tried some of the large language models with text, right? You ask a question, then you get the response as a text. But NASA and many others are dealing with a lot of geospatial data. It wouldn't be great to have that ability also to ask questions against the geospatial data. For example, in this case, we're asking the question, how was New Orleans affected by Hurricane Ida, in September 2021, right? So given that it has access to that back-end geospatial data, it's providing me with a text answer, but it's also giving me the imagery, right, and showing me all the different affected areas that I can then take and analyze. So this is something that we have co-developed with NASA, with the Marshall Center here, but there also other customers can take that and deploy it within their environments and then use it with their own geospatial data. And the use cases are, of course, vast. It's not just around understanding the impact of a hurricane or some other weather event, but you can think about, for example, buildings in specific areas, understanding the geological composition of the area and making sure you are doing it correctly. But also think about the use of this when you are dealing with someone maybe who is not a cartographer, geographer, or who is not really very well versed in the geospatial data, analysis of geospatial data, but still needs to work with it. So this lowers the entry point also to upskill others. And there's another collaboration with NASA. This is what they call Hydrology Copilot. Everybody loves the word copilot, and apparently they adopted that too. But this is really framework and an agentic system that NASA built together with our team as we are supporting them to understand what and reason over their hydrology data. So again, all of that data that is around hydrology, they can now ask questions and get answers very quickly and get accurate answers. Another interesting use case is with the nuclear industry. Again, as I mentioned, Microsoft, lots of data centers, and we're always also looking for sources of energy that can power the data center without really having a lot of impact on the resources. So we have, and you may know that when it comes to the nuclear industry, the permitting and licensing process is really backlogged. There's a bottleneck for licensing and permitting. And it's not just in the United States, it's actually across the world. So what we have done is that we've put together all of those different capabilities that Heidi was talking about within the Foundry and different models, and build an agentic framework that can generate accurate, technically complex, large documents based on lots of the different data, disparate data sources and data types, and create the permitting applications that will be much faster than if you're doing it from scratch. So think about large documents, complex documents and reports of 200 plus pages that are generated within 5 to 10 minutes. And those are accurate and based on the structure and outlines that you provide and you can control. So one of our public customers of this is the Idaho National Lab, one of the 17 labs within the Department of Energy, and they're using this technology to generate nuclear safety analysis reports. This specific solution doesn't apply only to the nuclear industry. We made it generalizable and industry and topic agnostic, so you can actually use it with any other, within any other discipline, within any other topic, simply by making sure that the backend data that you have is supporting generation of that kind of reports. And another interesting application of AI and various models is, of course, atmospheric prediction. I told you that I landed with a 10-hour delay from DC yesterday, and that is because we had snow. When snow happens in DC, even half an inch, everything stops. But we knew about that, right? We knew and were prepared. Roads were salted, shovels were bought, and husbands were told that they need to shovel. But if we didn't have that atmospheric prediction, if we didn't have the models that are helping us to predict weather, we wouldn't know about that, right? So we have very powerful models when it comes to weather prediction. One of them is Aurora. It's specifically purpose-built for predicting weather. And that is something that is being used by several organizations across the world, but also by NOAA. In NOAA, we have lots of different collaborations also with NOAA when it comes to understanding the data, reasoning over the data, applying these different AI models to various mission-specific work that NOAA is doing. And one of the last use cases, but definitely not the least, is the example with Sandia National Lab, another lab within the Department of Energy. They were one of the early adopters within the US government of AI, and they have used it as their own secure chatbot for the data that they're using, so to make sure that their employees do not go out of their own network and use mass commercial products that may not be secure. And they've had amazing response from their employees on how they were using that. They were saying that they were saving 3 minutes per question with the AI chat. Heidi talked about saving 1 minute is a huge deal already, and it's just saving whole 3 minutes. And they were asking, and this is at the very beginning also when they were just deployed it, they were getting over 100,000 questions a month within that chatbot. And finally, this is also kind of exciting one, especially if we're dealing with NASA. Think of all the rovers that are out there, right? Magma is one of the multimodal agents that was developed by Microsoft Research. Microsoft Research is one of our divisions that is specifically focused on cutting-edge technology. A lot of their research goes then into our products. So Magma is a multimodal AI foundational model that is designed to process information and generate action proposals both from the digital and from physical environments. So let's say your robots, for example, that have the Magma model on it, right? They are connected to the Magma model, can take stock of the surroundings and then suggest specific actions based on what they see. And I want to conclude the slides portion and go back to what Heidi was talking about, how we are seeing that agentic AI transformation, right? Something I would definitely encourage you to think about is the use cases. Again, think about what you are trying to solve. What are your requirements, your pain points, and then based on that, you can then understand how to apply, how to adopt, and how to apply AI and AI agents. So Heidi and I will be here. If you have questions, please ask them here or maybe a bit later after the session is over, and let's talk about how you are planning to innovate. And one more shameless plug here is we do have a Copilot workshop on February 3rd. Here in Huntsville. So please feel free to register. There's the QR code. If you have any questions about it, also let us know. I'll stay on this slide for a couple more minutes so you can take advantage of the QR code. And then I think we still have a bit of time, so I can show you some actual live demos if the demo gods are with me today. Okay. And the slides were shared with the organizers, so they are okay to be distributed. Okay. Let's take a look at what we're all talking about here. And this is live. So hopefully the network is fine, the Wi-Fi is fine, and it's actually working the way I need it to work. So Heidi mentioned Foundry. I mentioned Foundry. That is really the backbone and the foundational platform for anything AI that we're doing. And this is where you can build and develop your own AI solutions and your AI agents. So we're talking about different models, right? There's so many models on the market. And then sometimes I hear customers say, which model should we choose, this or that? And this is, again, when I tell them, think about your use case. Your use case dictates your model. The model that is popular today may be obsolete next week. So, but when you have a platform that allows you to choose from, as of now, 296 models, you are not tied to one model that may become obsolete next week. You are actually working in a platform that allows you that innovation, that allows you to bring data securely, choose the model based on the use case that you are working on, and then test your AI agent, iterate on it, and then deploy it to your users and then monitor it. So you can, in the Foundry, you can choose from all the different variety of models that are some frontier models, general large language models, but also different specific task models. For example, you can, and then, of course, I am not able to remember all the 11,000 that we have in the catalog. That's why you have all the different filters to see what you're actually trying to do. And then different inference tasks that may be useful for your specific use case. So building agents. Foundry allows you to build a simple agent without writing a single line of code, but also you can open this up in your VS Code, for example, and use Python and do your development with code. Today we'll stay low code. And before getting here, on my 10-hour delay, I spent a few minutes, and I'm not exaggerating, a few minutes to build a quick agent that would be relevant to our talk today. So what I have done here. So I have taken some files from the public NASA website, specifically about health. Astronaut health, what kind of symptoms or syndromes you may get when you are in the orbit. So I've taken some of that data, popped it into my agent. That data was indexed and now presented to my one of the large language models that I have deployed here. So my idea here is that I want to build an agent which I can ask questions around astronaut health, or maybe some symptoms that they are displaying, right? And then I want this agent to be very specific, to give me answers only from the data that it has access to, which means it will not hallucinate. You probably also have heard the term hallucination. It's when the model is trying to be really helpful, but is making up answers, right? And that are not exactly accurate. That can happen when you are using, again, those mass consumption commercial products. But when you're building your own, for example, with Foundry, you can control that so you don't have hallucinations. Because you can make sure that the answers are given only from the data that is provided. And also, you can play around with different parameters here and settings that allow you to control how creative or how deterministic the model is. So I like facts. So the first thing I do if I'm building something, I go and I reduce the temperature as much as I can. So temperature is really one of the parameters that is dealing with that, the creativity of the model to give you some different answers. So the lower it is, more deterministic the answers are, and based on the data that you have provided. Higher it is, more creative answers you get. So I don't like fluffy answers, so I even sometimes give instructions to my model to give me bullet points. I don't want the narrative, I just want something that I skim very fast. So, and you can give also instructions here. So right now, I'm going to read it out so you can all see. Instructions can be whatever you want your model to do. So in this case, I'm saying that you're an agent helping users find information related to health in space. You will provide only responses grounded in the data and knowledge provided. Each response should end with, please note that I'm not a medical professional. If this is an emergency, contact a medical doctor. If you don't have a response to a question that is grounded in data and knowledge provided, say, I lack facts, I don't have enough reliable data to provide you with an accurate response. Instructions can change to whatever you want. You can say, if you don't have information, say, oopsie daisies, I don't have the information. So really, that's instructions is your oyster to come up with whatever direction you want your agent to go to. And then, I also added an action. An action here is that I want to send an email. After I have that back and forth with my agent, I wanted to send an email. But instead of me going, copying this, maybe putting it in a Word doc or just even in the body of the email, I just can say, send it in email to someone, right? Without me clicking more. And that may save me another minute. So let's ask the question here. I want to ask, so let's say one of the astronauts, look at that, I spelled astronaut correctly. One of the astronauts is displaying the following symptoms. And I jinxed myself, symptoms. Let's say general fatigue, some dizziness, and probably a medical doctor would have better wording for all of that. But again, we are thinking about people who are not doctors, but they want to have some kind of initial information, right? Some dizziness, and let's say minor headaches. What could be the root cause of the symptoms? And remember to talk to your AI agent or your AI model as you would talk to a person. We as humans, we want to pretend that we are really good at reading between the lines or understanding hints. We are not, in general. The same goes about AI. As clear your prompt is, the clearer answer you would get, right? Okay, so you can see that here it gave me an answer, and at the end it also said what I have instructed it to say, that it's not a medical doctor, it's not a doctor, this is just some information based on the data that it has, right? Let me ask another question. What could be done to alleviate these symptoms? And again, this is based on the data that I have provided there. And I'm going to ask the question, how is the weather in Northern Virginia, where I live? By the way, I didn't understand the misspellings. I'm just a stickler to good spelling. Because I instructed it to not go out of the knowledge base that I have provided, right, the data that I got from the NASA website, it's not going to tell me how's the weather in Northern Virginia. It may know, but because I said specifically, don't talk about anything besides this portion, besides the health concerns, and give me this answer. Okay. And now, just for 1 second, I'm going to open my Outlook and then close it very quickly. Okay. I'm doing this because I want to send the email so you can see the email then coming in. Okay. So I'm going to say thank you. Now send this by email to, and then say myself. Okay. So I can mention anyone else, or I can also add those in the initial instructions in these actions here to which emails I want to send it. But here I left it free, so I can change that email address anytime I want to. Okay. I'm on a don't disturb mode. That's why you didn't see the little email pop up there, but it appeared here. So what it did is it sends me an email with all that information that I have talked about. You can set up it to send an email to someone else also, of course. So this is a really simple kind of retrieval agent. Remember that continuum that Heidi was talking about, right? Retrieval, task, and advanced automation. So this is an agent kind of in the middle, right? Because it retrieves information from the data that was provided, but then does an action on your behalf, sends an email. Again, this is pretty basic. You can also have a multi-agentic system that sends an email, then goes over the reports, checks for something, and then sends it for review, reviews it, and then goes through that additional workflows that you have set there. But that's it, I think, for today. And please ask any questions that you may have.
Hey, that's very loud. Jeff Gray, senior AI ML scientist. Very impressive demo. Very interesting, and I too like to tempt the demo gods. I did have a question sort of about the length of your chats. A lot of these systems, even though you turn down the temperature and give very explicit instructions, they can start to break down as the chat lengthens. And I'm wondering, under the particular circumstances you showed, if you guys have tested it to see, you know, at what point maybe it starts providing answers outside of what you would like, or it starts, you know, it stops appending things that you want, or maybe starts hallucinating.
Yeah, great question. So the prompts were not very lengthy, and also the answers were not very lengthy because it was a quick demo. But when you have larger prompts or larger documents, let's say, that you need to feed to a large language model, that is when you would need to do what's called chunking. You're probably, you know that. So you would chunk those data sets. Let's say you have a 200-page report that you would chunk that into smaller, more digestible portions. So the large language model is easier for it to retrieve the necessary information. So when you do that, you then can also index the data and vectorize it, which would mean that you are finding the different data points that are relevant to each other from different data sources. And that on its own, it's going to reduce the hallucinations also.
So one of the things that I learned kind of referencing the question was just asked is, I think in standard Copilot, they cut you off after 30 queries, is what we learned last week, because I kept running into that boundary and was wondering why it kept telling me that the conversation is done. But anyway, my question is, you know, I work with the city of Huntsville, and we're experimenting with Copilots, and there's many different environments that you can build Copilots in. So Copilot in M365, Copilot build in Copilot Studio, and then agent build in Foundry. Number one, is the marketing team ever going to not call something a Copilot so it's not confusing to all of us? That's a joke. But number two, what is the differences between those three environments, and where should we be experimenting with building agents kind of at a municipal level?
Okay, so here are those various different Copilots, right? So think of it as, again, what is your use case? I may sound like a broken record, but what is your use case, right? And think of your use case. Is this something that you can buy or build? So when we talk about M365 Copilot that you're experimenting with, this is a great tool for productivity, efficiency, for the data that is within Microsoft 365 suite. And that means all of your data within SharePoint, OneDrive, Teams, Excel. I want to build a PowerPoint from a report. I don't want to build a slide. I just feed it to the Copilot and it can build something for me. My Teams meetings, let's say, I'm sure it never happens to you. Sometimes it happens to me that I'm late to a meeting. And instead of asking one of my colleagues, did anyone say anything that I need to know about? The Copilot is on. I can just ask Copilot, hey, well, recap the meeting for me. Has anyone mentioned my name? You can do that. Or you're coming back from vacation, and there are 5,000 emails and 10,000 Teams chats, and I want to know if anyone I need to pay attention to has emailed me, and I'm like, has Heidi emailed me? I'll take a look at those emails first, for example. So that's the productivity and efficiency in the M365 environment, where you can build those quick agents in a low-code environment without any code, right, on the data that is in your SharePoint. Okay. Let's say when we have, but what if you have data that is not just in SharePoint, it's on a SQL. It's in Oracle. It's maybe in a different cloud. It's also in Azure. You have something on-prem. And you have a use case where all of that data needs to talk to each other instead of you going to each individual data source and wasting all that time. And on top of that, let's say you need help with generating a 200-page report. That is a more complex, not complicated, but more complex use case where M365 Copilot on its own will not handle. This is where you need Foundry's help. And Foundry is that, again, that development platform where you can connect to those multiple data sources, bring them together, correlate them, chunk the data, and then, if you want to, surface it through your M365 Copilot experience. And then if we're talking about these other ones too, the security Copilot is really for security professionals. Let's say, think of CISOs, for example, right? Or anyone in the cyber, and you can use that to understand what is going on your network, reverse engineer malware, secure your networks, etc. GitHub Copilot is your best friend if you're a developer. If your job is to develop applications, you work in code, all you have open on your screen is VS Code, for example, then GitHub Copilot is your friend because it can help you, for example, convert comments to code, debug your code, help you with, maybe you need to do something in a language you don't really know yet that well, help you with that. And in many cases, because we're dealing also with customers who have a lot of legacy applications, written, for example, in Fortran or COBOL, but we don't have the younger generation of developers who knows those languages. GitHub Copilot can help with converting those languages to a more modern language, let's say Python or C# or whatever else you prefer. And that takes a lot of that grunt work out, where you can actually then work on modernizing your applications. Helpful? Okay.
Hi, Neil and Heidi. Thanks for the great presentation. My name is Nubal. I'm from Boeing. I'm a former Microsoft research intern too. So as you referred that Microsoft Research and models, I was recalling my days there. So I think I really like the way you showed the spectrum of agents, like going from rule-based all the way to fully autonomous. Our community is very confused with fully autonomous things are the agents, right? So glad you brought that point. I'm going to talk about that later as well. But my question now is, I think when we talk about these different solutions, you showed how quickly we can build an agent, right? That's great. But I don't see you discussed about the quality of the output it generated. It may have missed it. And also, I didn't see the guardrails that we need in agents. So could you elaborate on those topics?
Sure. And I'll even show you a bit how you can do that. So,
use that one?
okay. So you have it has here AI quality, et cetera, right? But then within the Foundry, you also have specific capabilities that can help you with the evaluations. You can have a manual evaluation, meaning that you are creating a specific type of evaluation against which your AI responses will be assessed. Or you can also have the automatic one that is kind of pre-built in there. You also have the guardrails and controls here that I can show you. And these are around content filters. There's various content filters that you can create and add to a specific model deployment. That, for example, this one looks for any content that is violence, hate, sexual, or self-harm. Then you can also add additional prompts against jailbreaks or indirect attacks. And then you can also create your own specific content filters. I get sometimes questions from customers, how do we make sure that our users, let's say, don't put their social security number in the chat? Okay, first of all, that your users need a lot of education on data privacy. But if you want to do it with technology, you can create, for example, a block list. I can create a block list. I'm not going to do it right now, but you can create a block list that can either block specific phrases, words, or regular expressions. And regular expression is a representation of, let's say, different terms. So I can write a regular expression that says, block anything that resembles a 9-digit number with or without dashes. And as a response, tell them, don't be naughty, don't put your social security number out there. So those block lists can vary, right? So that's one way to do that also. Then another one of the kind of guardrails that a lot of customers like is adding additional alerts, for example, on your index of your data that if your users are searching something that they're not supposed to, you will get an alert about it. That search, that prompt can be blocked, but you as an administrator can also get an alert. So there are a lot of different things that we can spend hours talking about how you can put those guardrails around.
Do we have any more questions? Yep. We get about 10 more minutes.
Thank you so much for this. I run Mars Micro School, and I have teenagers, and I'd love to make them a model. The one thing I'm really worried about is cost. So I wonder if you could give some tips when you have a bunch of teenagers who, when you give things like this to them, the engagement goes through the roof, and they'll be clicking a lot. So how can I make them a model that might have all of their education in it, that they could learn directly from without killing me in cost?
I may give that question to Heidi because she actually has kids. She has the control. But I'll tell you a funny story before that. So I do these presentations a lot, but my audience is always adults. One of my colleagues asked me to come talk about AI to a bunch of fifth graders. I was like, oh my God, how am I going to make it interesting to kids so they don't fall asleep? So I created my slides, and then I asked the Copilot in PowerPoint, change the wording of the slides so it would be relevant and relatable and fun for fifth graders. So as you can imagine, there was a lot of slay in the slides and a lot of funny things added.
All right, so when it comes down to cost for your specific use case, right, I think, again, it comes down to that model. And so in your instance, you're probably not going to use something like Foundry, right, I would assume, because that's more for enterprise-grade kind of AI. And so you're looking at point-in-time AI. And so, you know, it's almost like you need a cheat sheet of all the different ones that are out there and what those costs are, and then you limit it in that way. I know me personally, because I do have children, and sometimes they come home with not hard math problems, but you know, like math has changed a little bit. I actually just use the free version of Copilot, and I've even said, do this problem like I would have in the 90s, so that I can remind myself how to do the math problem, and then I can look at how they're doing it and say, okay, well, we derived at the same answer. And I actually use that as an opportunity for them to teach me like the new way of math. And it's really interesting how the thought process is different, but the answer is the same. So I don't have a super great answer for you of like, you know, here's 10 models that are free that'll help minimize your costs. I would say make sure that you track it. You could potentially build an agent to set up an alert, right, to tell you when they're exceeding a particular cost for a thing. We do that internally, like Nelli might build this great demo, but if she forgets to turn it off, it's going to send me an email and be like, hey, Nelly's still running, you know, whatever. Go call her and tell her to turn it off, because we do, you know, internal chargebacks and all that fun stuff. So to apply it to, you know, an organization in that way.
Thank you so much for the presentation. So I'm thinking about Heidi's evolution of AI within the organization from RPA to agent orchestration. So coming from an organization that doesn't have a deep penetration of RPA within it, when you're working with business, oftentimes when they think AI use case, what they really need is just some Power Automate. It's not necessarily AI, it's just a catchy word. But from the strategy perspective, do we just skip that step and kind of look over for solutions that bypass the need for simple RPA, or is there still room for those tools of yesterday?
I think there's still room, right? And when you look at it, especially when you look at it from a business perspective, you want to use the thing that makes the most sense and is the most cost effective for your business. So oftentimes we talk to customers and they're like, I want this latest and greatest model that just came out. And our first question is, why? What are you using it for? Because you might pay X for that, where you could pay a fraction of it for Y that is older and will do the exact same thing, and it's not going to necessarily get you a different output, right? So that use case development is really, really important. And that's why when I talk about the frontier firm and those different phases, right, organizations are going to be across all of those phases. You want to use the right tool in your toolkit, right? Just because you have a hammer, not everything is a nail.
Quickly add something to that. Also, fully agree with Heidi's assessment. And something else you may want to think about is just think ahead of what this use case of RPA may evolve into. So do you really spend, the RPA may work, but are you working, would it evolve into something in, let's say, 2 or 3 months in a short term that may need more of an agentic workflow? So probably in that case, then it makes more sense from the efficiency standpoint to go with agentic. But if you know that for the next couple of years this is what you need, then why do that, right? And something else when we talk to our customers about like how to prioritize use cases, one of the things I like to mention is risk. But it's not the risk of security or safety. It's the risk of falling behind. Especially if you are in a competitive industry, are you falling behind by not adopting AI from your competition? So.
All right, we've got enough time for maybe one more question if there's any.
I have so many questions, so this is my number 2. I know you guys talk about space and use cases about that, right? So I want to know about some of the limitations? Like, because when we take the models to the space, maybe we don't have that, capacity like we have here, right? So what kind of considerations you see from your customers bringing these powerful models to the space? Are there hardwares already available, or are you guys working towards that? Any thoughts?
We can't go into the roadmaps too much, but let's say right now, if you want to have AI, right, in a, let's call it a disconnected environment, you can, because there are large language models, but there are also small language models that can be often, depending on the model, as performant and very useful for your specific task. And we do already have customers who are using those small language models in those environments, so that can be one of the solutions.
All right, everybody, thank our guests this morning.